my life. Third one was on YouTube. I didn't get on silent.
One here. If you take 3 and plug it in where x is, this negative stays outside. Okay? Following order of operations, you square 3 first and you get negative 9 plus 9 minus 10. And then these two cancel each other out and you end up with negative 10. Yeah? All right, how about number 4? A square flower garden has a perimeter of 24 feet. Wait, what's the key word here?
Square.
So all the sides are what? Same length, right? So I can represent that with x. So I could write x plus x plus x plus x, or I could write 4x equals 24. And then divide x equals 6 feet. Okay, here we go. Let's have some fun. You ready? All right, consider this relation. A relation is a pairing of input values with output values. You can write a relation as a set of ordered pairs. Okay, x is going in, 2 gets pooped out. Negative 1 is going in, 0 gets pooped out. If your parents are watching this video right now, they're like, what the heck? Okay, 2 is going in, negative 1 is getting pooped out. Okay, it's live. All right, so you guys, shh. X is the input, Y is the output. X is also the what? The D word, which is what? Domain. So we've got to list all the inputs. That's the domain. 3, negative 1, 2, negative 2, 0. They're not in order right now from least to greatest, so we probably should do that. So you could write it in an ordered pair, like a bracket like that, and it would be negative 2, negative 1, 0, 2, and 3. Okay? Or you could do either way. Okay, the range is a set of what? Y's or outputs or poop. So you just list the Y's, okay? 2, 0, negative 1, 1, and 3. That's all the Y values. And you list them in numerical order to do it properly. That's a 2 with a comma. Okay? Represent the relation using a graph and a mapping diagram. So what they want you to do is they want you to graph all these ordered pairs. Okay? So go ahead and do that real quick.
Wait, why didn't you send them up in order?
That's a mistake. Okay? Now the mapping diagram. Claire, this answers your question. The reason we have to put it in order is when you do a mapping diagram of all the inputs, they have to be in order from numerical least to greatest. Okay? So we have to write a mapping diagram. So we're going to list them here. Negative 2, negative 1, 0, 2, and 3. And the outputs, same thing. You have to put them in order. Negative 1, 0, 1, 2, and 3. Gentlemen. Hi.
That's on the video now.
Okay. Yes, it is. All right, so now we have to map. So we go to negative 2 in our set of points. Negative 2 mapped to what number? So negative 2 went to 1. Okay? You guys do the rest of them real quick. Go up to the ordered pairs so you can see where they map to. Okay, that's a fun little map. I have a question for you. Does every input have exactly one output?
Yes.
Yes, it does. So yes, it's a function. Okay? Like for instance, 0 is going to 3 and 0 is not going to any other numbers, is it? So it's good. Okay, turn it over. So you have to decide by looking at the mapping diagrams, are they functions or not? Take a look here. Do they each go to exactly one output? No. No. This right here, sick fish. Okay? Sick fish, it has indigestion. So to be more specific, explaining is no, it's not a function. 3 has 2 outputs. Not possible. Every input has to have exactly one output. Okay? How about this one? Is this a function? Yes. Yeah. Every input has exactly one output. Even though they both go to 5, it's okay. All right? Okay? It says explain. Okay? All right. Do you guys remember the vertical line test?
Yeah. I don't remember how to do it, but
Vertical line test. Sometimes abbreviated VLT. If you're given a graph and it's asking you if it's a function, what you do is you can draw a vertical line through each point, and that line should only hit one point on the function. If it hits 2, it's not a function. If you think about it, I'm going to add something to this map. You don't have to. Look, if I had another one here, another point here, along with this point, my vertical line would be hitting 2 points, right? And that's not a function, because that's saying for the input of 12, there's 2 outputs. That's not true. Can't happen, right? So this is not a function. Oh, I'm sorry, this is a function. These both pass the vertical line test. Look, vertical lines. My vertical lines only hit 1 point, correct? Okay, so both graphs represent, don't say just yes, you have to explain. Both graphs represent functions because, I'm going to abbreviate BC.
That's not measures.
Yes, it is. No vertical line intersects either graph at more than 1 point. What form is this in? And B is the what in the graph? B is the y-intercept. Begin with B, if anybody had Mrs. Selectman. Begin with B, that's your starting point. Begin with B. It's your starting point. Begin with B, it's your starting point. So they're saying here that -5 is my y-intercept, that's my starting point. So I plot -5 on the y-axis, remember? Go down 5, 1, 2, 3, 4, 5. There's my y-intercept right there, -5. And then I use the M, what's the M represent? Slope, which could be thought of as rise over run, correct? So if I start at -5, the slope is telling me I need to do what? Go up 3 and over 1 to get my second point. I got 2 points, I can draw a line, correct? So up 3, over 1. Voila. You graphed it. Okay? So again, where's my starting point on this graph? -2. It's kind of hard to see here. Begin with B. Negative 2. That's your first point. How do you get your second point? 3 over 1, correct? So up 3 over 1. It's kind of hard to see. I'm just going to guess where it's at. Oh, now wait a minute. What do you notice about both of those lines? They have the same slope, but different y-intercepts, correct? Oh, so this is like a refresher. If two lines have the same slope, they are what? Okay, all right. So tell whether the function is linear. Because mx plus b represents a linear function, right? What's the exponent on that x? What's the exponent? What's the exponent on this x? Yeah, it's there, we just don't write it. The exponent is 1. Okay, it has to have a degree of 1 or an exponent of 1 or it's not a linear function. Does this have an exponent of 1? No. So just for fun, if you can't remember, you can graph this. It's really a fun graph. And you can see, if you were to graph it, why doesn't everybody try graphing it real quick? Okay. Exponent is 3. Or a degree of 3. It does not look like a line. So if you just can't simply remember, you can always whip it on the graphing calculator and see what it looks like. Does it look like a straight line or not? No. That's because the exponent is 3. Okay? If you were to stick in negative 3 here, it has to be like this. Do you remember how to do a cubed on the calculator? I use the caret key. That's what I call it. That little key like that. Yes, this is linear because this has an exponent of 1. It is a linear equation. Okay?
So if it has more than an exponent of 1, it's not.
Right. If it was squared, what would that be called? Do you remember? Yeah, it graphs a parabola. It's called a quadratic equation. Okay? So, if you were to plug in negative 3, you get 36. Okay? I didn't tell you what this would be. This would be 59.
Do we need to know that?
Well, that's what it says. Evaluate.